Networking, Part 7. In this nugget, we're talking about troubleshooting tools for networking. I don't really have an introductory whiteboard for this one because the only whiteboard I have identifies every single item I'm going to talk about individually anyway, so we'll just use this as we get started. Now, when it comes to troubleshooting networking, you have several tools at your disposal that you can use to help assist you with this, starting with ipconfig, and I list that one first because unless you understand something about your own IP configuration, there's not really a lot you can do to troubleshoot other areas of networking. First of all, you have to, of course, have an IP address, and you need to know its default subnet mask and whatever subnet mask you're using. You have to know some other things such as the default gateway, whether or not you have a DNS server configured for it, and so forth. So here I've just gone to a command prompt. Actually, I got several open, and the reason for that is because some of the commands take a little bit longer to process, so I started those in advance. But I'm going to do an ipconfig, and then as with all of our other commands, you can follow it with a /? to get all of the syntactical information about this that you might need. But in our case, I'm just going to do an ipconfig. Now, once we do this, notice that we get a few different things, and I'm going to kind of go over the main parts of this. Number one, you do get tunnel adapters, which are used in current versions of Windows. Those don't really have any direct bearing on network troubleshooting, however, because any of the troubleshooting we do for connectivity purposes will be on your local area adapters. These are your physical adapters. Now, in this case, I've only got the one, and you can see here that the first thing might raise a question. It says connection-specific DNS suffix. This is accusource.local. What that means is, if I try to find another computer on the network by a single label name only, in other words, maybe the name of the computer is PC1, and maybe I was trying to ping that computer just by typing ping space PC1. We'll talk more about ping later on. But anyway, since I did not give a domain in that command, what's going to do is it's going to append accusource.local to the end of PC1. So it'll be pinging pc1.accusource.local, and if it can't find it there, then it'll also try nuggetlab.com, which I don't really use a lot in this particular series, but when I do training on Windows domains and Active Directory, I use that quite a lot. So it'll try both of those first, and if it can't find anything there, then it won't be able to resolve anything in either of those domains. Notice that we also have an IP version 6 address. This looks quite a lot different than IP version 4. It is also quite a lot more complicated. It's actually 128-bit address, and we don't really need to go into a lot of detail for A+ purposes because it's not even on the exam or in the objectives. But one of the things you'll notice here is that sometimes you'll have a ::. It's kind of a shortcut so that if there's consecutive zeros there, it can cut those out and just put in : instead. But anyway, yes, it is a 128-bit address, and it's got substantially more flexibility than IP version 4, but also quite a bit more difficult to understand. Here's my IP version 4 address, though, and for A+ purposes, that would be one of the significant things to know. So I need to know my IP address. I also might need to know, of course, my subnet mask if I'm having troubles with custom subnet masking or something like this, or if I suspect that a subnet mask has been incorrectly entered, maybe just by a typo or a human error even. We also have a default gateway here. This is important in terms of troubleshooting your default gateway. For example, what if I'm not able to get to the internet, but I am able to contact other computers within my own local subnet? Well, the ipconfig command will help me to identify what my default gateway is, and then what I would do in the next step of that is I would ping that particular IP address to see if I can reach my default gateway. Now, as we take a look at this, I also want to point out that you can do a number of other things with ipconfig besides just showing information. First of all, maybe this isn't enough information. For example, it doesn't say anything about what my DNS server's IP address is. So I could do an ipconfig /all, and that gives you more verbose information. So you can see here now that I'm going to get more detail out of this. For example, I'm going to get the description of the network adapter. Okay, so again, you can see I'm using VMware here. I'm going to get the physical address. That's also known as the MAC address. We've talked about that before. It tells me that I am using DHCP, and then I'm automatically getting the configuration from the DHCP server. On the client side, what this is really saying is I'm going to automatically obtain my IP addresses. And then here again is the IP version 6 address with IP version 4 right here. And some of the rest of this we've already seen. Here, the lease was obtained on this date and time, and it's going to expire on this date and time. Now, just so you know, it's not an A+ thing, but part way between the time I received the lease and the time that it expires, it will attempt to renew about halfway through, just to make sure that I don't lose the lease on this address anyway. But in worst case scenario, if this date and time were to pass and I had not yet renewed the IP address for some reason, it could have been a laptop that was closed, or and powered off, or something like that, or in suspend. And then I wouldn't lose this IP address, and it might be given to a different client. So I would no longer have that address for this particular computer. Then it also tells me the default gateway. And we'll talk about that here more in a little while, because you also need to know how to troubleshoot your default gateway and my DHCP server's IP address. And again, some of the other things we see here that are of particular importance would be things such as the DNS servers. Now, this is important because you can see that in the scope for this DNS servers options, I've identified 3 DNS servers. And why did I do that? Well, again, this isn't just for your information, not for A+, but that's the one I normally use in my own corporate infrastructure. However, if that server is down or offline for maintenance or something like that, my clients, I still want them to be able to browse the internet, so they're using the IP addresses from my ISP here, DNS servers. So anyway, that gives us the main thing here with all of our various commands there with ipconfig, and now I want to show you a couple of others. I want to clear the screen and just type CLS, and of course it cleans up for me. So some of the other commands we might be interested in would be maybe an ipconfig release and or an ipconfig renew. Now, the way this works is this. Let's say that when I first received my IP address, let me start a new little whiteboard here. When I first received my IP address, and this is my computer right here, and this is my DNS server right here. Well, when I first received my IP address, one of the things that it told me was I'm supposed to use DNS server, 10.10.10.8. Okay, and that might be 10.10.10.8 over here. However, in the time that I received this address, which let's say it's a 7-day lease, and that's a common duration. Well, let's say after 2 days, this server went down, and we had to replace it with a different server on a different IP address, and it was .5. Well, now the problem is I've got a stale address here, and I'm not going to be able to use the DNS server at the proper address anymore. So what I want to do is I want to change my DHCP server's address for the DNS server. So I'll change it to .5, but that doesn't do anything for this client over here right now because I still have the stale address. 7 days haven't elapsed yet, so it's not time for me to renew it, and I'm still going to try to use the old one. So what I would do here is I would use a couple of these commands. I would use an ipconfig /release. Okay, that would completely release the IP address and all of its configuration from my network adapter, and then I would not be connected to the network anymore. You do have to be a little bit careful about this if you're remotely administering this over the wire, because when you lose the IP address, you lose your connection to that computer in the first place. So you may need to be locally connected in order to do this. And then the other thing I would do would be after I had released it, I might do a ipconfig /renew. And what that will do is it will then seek out the DHCP server again, and when it does, it will then produce this as the IP address for my DNS server. And so then instead of having .8, now it'll go to .5 when I renew the address, because it not only gives me a new address, but also all of the other configuration for which the DHCP server has been configured. Let me show you another command here that you might use. This one relates to DNS, and that would be flush, oops, scrolled up there, flush DNS. Now, what's that about? Well, you see, whenever I try to look something up and resolve a name against an IP address using DNS, it'll cache the result in a small portion of memory. The advantage of that is that if I have to access the same location, usually within an hour, then instead of resolving it against the DNS server, and using the DNS server's resources, it'll just retrieve the previous result out of cache. Okay, so it's much more efficient that way. Normally, this is a good thing. But what were to happen if I were to access my company web server at a certain IP address, and then the very next, within 5 minutes when I tried to go back to it, it would say web page not found or some other kind of an error message. Well, that didn't seem to make sense because I was just there and maybe we were sure that the web server is up. So how come I'm not able to access it? It could be that between the time that I first accessed it and the time that I tried to access it for the second time, the IP address of that web server changed. And this could take place with any kind of server or network device. It could be another client computer's IP address changed. It could be that a file server's IP address changed, or in this case, a web server's IP address changed. Well, you see what happens is, even though that address changed, the cache in memory did not get updated. It still thinks that that server is at the old IP address. So now what it's going to try to do is it's going to try to open that old IP address to access the web server. If I know that that's the problem, what I would do is I would flush DNS, and that would clear out the cache. Then if I were to try to access that web server again, it would produce a fresh query against DNS. And this, of course, assumes that when we updated the IP address for this particular web server, we also updated its IP address in DNS, and I'm going to have to do that if I want to get a good result. Now when I try to access that web server, it's going to resolve it freshly against the DNS server and get updated information. And I think you saw that command prompt just told me that I needed elevated privileges there, so I'm going to go back to a command prompt here and right-click on Choose Run as Administrator. Some of the commands you can type you don't have to be an administrator for, such as ipconfig and ipconfig all. Other things that may do a configuration change or alter anything about the computer will require administrative privilege, and if I want to flush the DNS cache, then that's one of those things. Okay. So here I'm just going to do an ipconfig flush DNS, and you can see here that it flushes the DNS resolver cache. Now another question that comes up is, I was talking about the web server's IP address changing. How would we properly register a new IP address in DNS? Well, you could go to the DNS server and create a host record, also known as an A record, for that web server. Very often we also use something else called an alias. But regardless, you make a record in DNS. The other thing that I could do, though, is if I'm at the computer, I could register it in DNS. So I could type ipconfig /register DNS. Okay. Now, most of the time with servers that we want to always be at the same IP address, we'll probably give them a static address, and we will also probably create a manual host record for them or an alias record for them. However, on a client side of things, if I wanted to make sure that my computer was properly registered in DNS, I would probably just type in ipconfig /register DNS, and then it will update that with DNS. And here it tells you that any server errors will be reported in Event Viewer in 15 minutes. Hardly ever do you see an error, though, provided your DNS server is online, and it does support something called dynamic update, which is where the client computers can update and register their own DNS host records. Now then, here I've also gone to the cbtnuggets.com website. In order to get there, I needed to have www.cbtnuggets.com resolved on an internet DNS server. So when I did that, it should have cached that result in memory. And I just wanted to show you this ipconfig /DNS, because earlier I mentioned that when you do have a name resolution that takes place, it'll cache that in memory for you. So as I press enter there, we now see that indeed it did cache www.cbtnuggets.com, as well as you can see there's some other things that are also cached in there that we also work with as well. Okay, so that's where you can display the cache, is with the /show DNS. All right, so ipconfig, very useful tool, and following on shortly after that one would be the ping command. We've used ping before, but the basic idea with this is to confirm that we can actually have a good IP stack loaded from the Windows operating system. We can also confirm that our network card is able to respond, and we can confirm that other hosts on the network, as well as the default gateway, can also respond. And the ping command, by the way, is an excellent tool that you can use to confirm whether or not the default gateway is working. In other words, troubleshoot that default gateway. So if I want to confirm some of these things, let's do this. If I'm having troubles with networking, usually you start in concentric circles, and I start as close to myself as possible and work my way out. So let's say that I'm having trouble getting to the www.cbtnuggets.com web server. And what I would do here is I would just first of all ping my loopback address. So I might ping, and then it would be 127 0.0.0.1. We talked about that earlier. That just pings up and down the TCP/IP stack that Windows created for me. This is what's going to allow networking to take place over IP. This is all software, though. It doesn't actually touch my actual network interface card. So if I know my IP address, which I forgot it, there it is, .36, then what I would do next would be to ping my actual IP address, which would get a response from the physical network adapter. So I'd then ping 10.10.10.36. Okay, I'm getting an answer there. So now I know there's nothing wrong with the IP stack, nor is there anything wrong, at least initially here, with the ability of my network card to respond either. So the next thing I would do is I would go another step out. I might see if I could ping any other computer on the network. I don't really know what my other IP addresses are, but let's just try one. I think I got .20 somewhere. Okay, now I'm getting a response back from 10.10.10.20. Now, if you don't get a response, that's not always a cause for concern. By default, our client computers will have disabled the echo request, which means that it's not able to respond from a ping command. And that's just a firewall setting that is configured. You could change that if you want to, but in fact, I did change it on mine internally because I wanted to be able to ping any of the hosts on my network just to see if they're actually alive. So in this case, again, remember, my problem is I'm not able to get to www.cbtnuggets.com. But I can get everything else right now. So it looks like my stack is good, my network adapter is good, and I can ping other hosts on my own same subnet. Now let me try to ping my my default gateway, and that would be 10.10.10.1. Now in this case, I'm going to get a response, but imagine, if you will, for a moment, that it says something like destination host unreachable or some other such error message. If I got an error message when I pinged that default gateway, that of course would tell me that there was a problem with that default gateway. It may be turned off, it may be removed, it may be unplugged, who knows what it could be. Very often in corporate environments, this will be something like a physical hardware gateway, such as a Cisco router of some type. And although it might be on my scope to actually fix that router, at least I know where the problem is, and it can be reported to whoever can fix it. Now here I just wanted to write these out before I went too much further along. Remember, what we did in this order was we pinged from as close as you can to as far away as you can to get to your destination. First thing I did was I pinged my own loopback address, then I pinged my own IP address, then another host on the same subnet that I'm on, and then last thing we did was we pinged our default gateway to see whether or not it's giving us a reply. Now, like I said before, if the gateway is not replying, then you need to troubleshoot that. If you're getting a response from the default gateway, the next thing I would try to do is to ping another host on a different subnet. Okay, so I might ping another host on a different subnet. In this case, I don't really have anything because I only have a single subnet. But I'll just say, ping www.yahoo.com. And then I'm getting replies back. I know that one's on a different subnet. Now, the other thing I might try is also to ping other routers that I know about. There might be it might be that my router is working fine. And remember, my router is the same as my own configured default gateway. Same thing, actually. But there might be another router on the network that actually is having a problem. Maybe that's why I can't access the web page or whatever it is that I'm looking for. So if the other routers properly give me an answer back, and they're sending back replies, then I might ping directly to the destination's IP address. And we talked about this in a previous nugget, but if I can ping it by IP address, but not by the name, then I know that there's a problem with DNS somewhere, and I'll start to take a different route of troubleshooting. But assuming that I'm not able to get an answer from the destination computer, then I may also try some other destination computer out there on the internet, or something, just to see if I can get any internet response whatsoever. This is kind of a sequence of events that you can take to troubleshoot where you might be running into problems with TCP/IP. Another tool that I might want to use here in this context would be traceroute. What this does is it identifies the various hops or routers or other network devices that my packets will go through in order to get to their destination. It tells me the name and or the IP address of each intermediary device between my computer and, let's say, the website that I'm trying to go to or whatever. And that's also very important because here, when we talked about pinging other routers, well, how do you know what those other routers' IP addresses are? There's no way for you to know unless you run a command such as traceroute. Now, I've already run traceroute in advance here, so let me go ahead and open that up. I decided to try to go to a location that seemed like it would be a little bit further away. Helsinki, Finland. It was a lot more fun than my own server on my own local network. But it gives me some replies here. Notice that I'm getting pretty quick in terms of millisecond response back from these clients. First thing is I went to my own default gateway, and I'm getting less than a millisecond most of the time on those. It tries it 3 times, and that way you can kind of get an idea for if you're getting a long delay in milliseconds on just one of those, then you know that that might be an aberration. But if all 3 of them are long delays, then you might know that there's really a legitimate problem there. But anyway, here we have another IP address. This is something that's from my ISP, and then we go out to ISP land here in Phoenix, and then I really don't know what the rest of these are. I just giving me IP addresses here. Some of them will resolve to an actual name, so it's resolving this IP address right here, which is probably a router, and it's giving it a name and a domain here, so we can help to identify where it might be coming from. And then you can see here that we're going into Helsinki and Valilai, or whatever that is. So lots of different locations there until I get finally to my destination. But it's this information that I can use in troubleshooting. So for example, this one right here, if I was getting 300 milliseconds or some really long consistent time here, then I might just try to ping that to see if it's actually giving me a good response in a timely fashion, or maybe that router is getting overwhelmed. Not a lot I can do about it on this end, but at least if I have a user complaining that their internet is slow, then I can identify what's causing it, and I might then at that point have to tell them that on the other side of the planet somewhere there's a router that's having a problem. It's likely that all of your other internet access will be at normal speed. Okay, so at least I know a little bit more having done this much. Now this gives me pretty good information, this traceroute tool. Another tool you might consider though would be one called path ping. Here I've done path ping www.helsinki.fi. This takes a little while. You have to wait for the results. It could take a few minutes to get them back. So I went ahead and did this one in advance, and you can see here that it goes through the same source to destination. So we get all the same hops that are taking place, but it also will compute statistics. What this tells me then is a little bit more information about whether or not I was able to successfully or unsuccessfully get to a destination, in addition to telling me whether or not any packets were lost in transit. Now another thing I can do with this, by the way, is, let me go back over here, is if I do the same command, I seem to have lost it, there we go. I do the same command, I can send that to a text file called path ping H for Helsinki.txt or something like that. Because here it's kind of hard to line up the columns, and sometimes it's a little bit harder to read, especially if these names keep wrapping around. Here I did that in advance as well, and you can see here that with path ping I have a little bit more readable format here. Actually, you can't show it that way because I don't have enough screen space. But you get the idea there. It tells me how many were lost, so we got good connectivity all the way through, nothing was lost, and how much was sent, and we have 0% loss. You would think that means 0% successful because it doesn't really say anything there. But this means that I was 100% successful and I lost no percentage of my packets. Okay, so and again, this just gives you, a little bit better data in terms of the overall source to destination success. Next, let's take a look at name server, which is NS, name server lookup. What this does is it helps to resolve problems with DNS name resolution. So for example here, if I was having trouble getting to www.cbtnuggets.com, I might want to find out what my name server was telling me in terms of what its IP address was. So I could type ns lookup www.cbtnuggets.com, and then it would tell me that this DNS server is the one that I'm using at this IP address, and the IP address that it's resolving for me is www.cbtnuggets.com is at 75.215.225.9. Okay, so that's the answer that I got back. Now, this DNS server here did not actually have the answer on its own. What it had to do was go through a series of referrals out on the internet, and it had to find the DNS server on the public internet that had the domain for cbtnuggets.com, and it gave me the answer back. That's why it's non-authoritative, because it doesn't have the actual answer of its own. Here, it just forwarded the request, got the answer for me, and then sent me the answer. Now, you can also use NSLOOKUP to resolve specific types of internet services that require name resolution and problems that they may be having as well. So, if I do an NSLOOKUP, and just press enter, it takes me to an NSLOOKUP command prompt. Let's say I'm having trouble with the mail server at yahoo.com. I can't seem to retrieve email from my Yahoo account. So maybe I'll go set type equals MX in this case. And then now I want to do is just type in yahoo.com, and it's going to assume that I want to look for mail exchanger records using NSLOOKUP. And then it tells me here what the MX records are for each one of the mail servers out there on yahoo.com. Now that bit of information is probably more than you have to know for A+ exam objective purposes, but I thought you might find it useful to know about anyway in terms of the real world. Next, let's go ahead and take a look at the netstat command. When we use the netstat command, and I'll just type it in without any other options here, we can see any active connections and established ports that are open. For example, we're actually got port 3389 open. Do you remember what port that is? Yeah, that's right, remote desktop. Okay, this desktop we're seeing, once again, is not the actual desktop that I'm using, because this is Windows Vista, okay, but I'm actually using Windows 7 to record here. Okay, so this is just what I use for demonstration purposes, as I've mentioned earlier, and I'm actually connecting through my Windows 7 computer. All right, so really, why is this important to know about? Well, if I suspect that maybe I've got a security breach and someone's accessing a computer without my knowledge or permission, I might do a netstat to see what established ports are open. And if anything doesn't look like it's a well-known established port, then I might investigate that to see what the foreign address is and see if that's somebody from outside of a network trying to hack in, or whatever else. I can also use the netstat command to identify my routing table, and I would do a -nr, for example, to check out my routing table. Now, this is the IP version 6 routing table, which is not really relevant on our current exam. However, the information that's useful for me right now is the IP version 4 route table. You see, what this tells me is if my computer tries to reach a certain destination host, how does it get there? And does it use a gateway? So, for example, if it does a broadcast, which is all 255s, well, that broadcast does not use a gateway of any kind. It only broadcasts on its own link in its own subnet. Okay, and it goes out through this specific interface. In other words, the loopback address. Likewise, it could also broadcast out through this address as well. So it's going to broadcast out of both of those. 224 is multicasting. Okay, and we can see that it's able to do that. Notice that here we have a whole range of 127, starting with .0.0.0, then our loopback address that's commonly considered the loopback address, and then the last loopback address. Notice that all three of those will go through our own link at 127.0.0.1. Okay, so that tells me, again, when I try to contact a destination computer on some other subnet, or on some destination, what method does it use to get me there? Notice that also anything on the 10.10.10. network from 0 up through 255, it will only use, again, on link. In other words, that it knows that that's going to be on my same subnet. And it's going to use my network interface card, network interface here, and that's what it does. But besides these known locations that we see all the way down through here, besides all of these, what were to happen if I were to try to go to an IP address, maybe a web page, that had 68.27.91.2? Well, none of those IP addresses or ranges are in this whole section right here that I've highlighted. So then what it does is it considers that 0.0.0. In other words, anything that I know 0 about, I don't know anything about that IP address, then I'm going to go to this default gateway to my router. And then I'll let the router handle it, because I don't want to have to fiddle with it. The router is going to forward the packets on to where they need to go, and it's going to return the packets back to me as necessary. So that's basically what that tells us. Oh, there's also this metric over here, by the way. What's that mean? The lower the number for the metric, that's also known as the least cost. So that means that the lower the number, the higher the priority it's going to have. And there's not really a lot to show you here in this particular context because I only have a single default gateway. But if I had more than one gateway, then the metric would identify which gateway to prefer, if at all possible, as opposed to going to maybe the second gateway. And then finally, there's a net command. This can be used a lot of different ways. You can use it for various types of services, various types of networking. You can use it to map network drives. And I think for the primary usage of the net command, you're going to see that we're going to use that primarily with things like net use. Not net user, but net use. You can use net use to primarily map network drives. Let me go ahead and show that to you here as well. Okay. Here, if I just do a net use, actually, let me clean the screen so it's a little bit easier to read. But if I just use a net use here, this tells me what my existing mapped drives are, H, S, and Z. All right. So I've got a home directory source where I've got all my programs that I install from and drivers and things like that. And then there's a VMware thing down here as well, which just makes a direct connection to my own actual local storage. Not really relevant for A+ purposes because that's vendor specific. But here are the things that are important, these top two. Now, what if I wanted to map an additional drive to an additional resource? Well, I would use net use, and then I would specify the drive letter I want. Maybe I want drive letter T, okay? And then I want it to go to DC1, which is my server, home, and maybe a specific directory this time, J Conrad, and press enter. Then it will tell me that the command completed successfully, so if I do a net use again, we now see that it's mapped to drive T right there. What if I decided that I wanted to prevent that or remove that mapped network drive now? I could do a net use / delete T. All right, press enter. Now when I press net use again, notice that it has now deleted drive T from that. Okay. Another thing you could use, by the way, let me scroll through my commands here, is that rather than using a T, if I didn't really care what drive letter it was, just as an FYI, I could do an asterisk, and it'll just use whatever the next available drive letter is, starting from the bottom of the alphabet. Current versions of Windows map drives automatically starting from Z, the bottom of the alphabet instead of the top of the alphabet. So you can see that it automatically mapped drive Y for me there. Let me show you something else here as well. One thing I could do is I could make a persistent drive mapping. So let's just say, let me remove that drive letter again. Net use delete Y. Okay. I could do a persistent drive mapping. That would be net use. I'll go back to T, so I have consistency there. And then the name of the share right here. I could also follow that with a / persistent : yes. Okay, and press enter. Now, what did I just do there? I made this a persistent drive mapping. This means that it will survive if I log off or reboot the computer. Now, the fact of the matter is that I think, CompTIA would consider this the only way to make it a persistent drive mapping. The reality is that all current versions of Windows already always assume a persistent drive mapping. You don't actually have to type this in. When I had typed that in, without that on the end, just like that, it was already persistent by default. I didn't have to specify that, okay? But I would just keep this command in mind because I think, the folks over at CompTIA think that this is the way to persistently map drives. It's really not. It'll happen anyway, so you might as well save yourself the typing. The only thing that I would want to do, though, is if maybe I only wanted it to be persistent for my current session, and I did not want it to survive, like a reboot or something, then I would do / persistent no. And that way, I would be able to use it for our current purposes, but not after a reboot. And you can see here that I forgot to delete it first, so let me just do that over again. Okay. And then I'll go back through persistent no, and we can see that the command succeeded successfully. And then now we can see all of our drive mappings once again. All right, well, as I said in the beginning of this particular nugget, I don't have a whiteboard for introduction because really it's just covering these troubleshooting tools, each one of which I already outlined for you. So I hope this has been informative for you, and I'd like to thank you for viewing.